It's not a myth, not a rumor anymore. A real interstellar comet glowing brighter every night, and scientists are watching because 3I Atlas is about to make its closest pass yet. This next story explains how this is a Christmas gift for astronomers around the world.
3I Atlas hasn't even reached its closest point to Earth yet, but fake videos about it already fooled millions of people. One channel was using AI to impersonate a Harvard astrophysicist. They cloned his face and voice, posted videos claiming 3I Atlas was alien technology, racked up over 1 million views in 2 weeks. The fake videos were so convincing that even a news outlet used the footage in their reporting. YouTube eventually removed the channel, but only after people started noticing details, like the clock frozen in the background, or the missing facial scar that the real professor has. If you've been watching 3I Atlas videos, you've probably seen conflicting information. Alien spacecraft, collision course, deadly gases. Some of it sounds convincing. So before you believe the next one, we're fact-checking the 4 biggest claims, with actual sources, NASA data, ESA observations, information you can verify yourself. Claim 1. It's an alien spacecraft. This is the big one. Videos calling it an alien probe, saying the gas jets are actually engines, claiming it's making controlled thrust maneuvers. Here's what we actually know. In August 2025, the James Webb Space Telescope pointed its near-infrared spectrograph at 3I Atlas. Webb can see the chemical fingerprint of gases, and what it found was carbon dioxide. A lot of carbon dioxide. The ratio of CO2 to water in the coma around 3I Atlas is about 8:1. That's unusually high for a comet, but it's still just carbon dioxide and water. Webb also detected carbon monoxide, carbonyl sulfide, and water ice. These aren't mystery substances. They're the same volatiles you find in comets from our own solar system. The production rates were measured. Carbon dioxide coming off at 129 kilograms per second, water at 6.6 kilograms per second, carbon monoxide at 14 kilograms per second. The Hubble Space Telescope estimated the size of 3I Atlas. The nucleus is somewhere between 320 meters and 5.6 kilometers across, probably closer to the small end of that range. For comparison, the Death Star in Star Wars is 160 kilometers wide. 3I Atlas is at most a few kilometers. That's small. And Hubble captured images showing a dust plume on the side facing the sun. That plume is exactly what you'd expect from a comet heating up. The Very Large Telescope in Chile detected cyanide emission, about 17.6 grams per second. They also found atomic nickel at 4.6 grams per second. Before anyone panics about nickel in space, this is normal. Other comets emit nickel. It comes from the breakdown of organic compounds when the comet heats up. The concentrations match what we see in solar system comets at similar distances from the sun. So where are the jets everyone's talking about? They're there, but they're not engines. When a comet gets close to the sun, frozen gases on the surface turn directly into gas. That's called sublimation. The gas escapes through cracks and vents in the surface. It carries dust with it. That creates jets. They point in different directions because the comet is rotating and the surface is uneven. Some parts face the sun and heat up faster. Other parts stay in shadow longer. You can actually see this pattern in the data. The Very Large Telescope observations showed the gas emission was stronger on the sunward side of the comet. That's exactly what you'd expect from solar heating. If these were engines, you'd see thrust in specific directions to change the orbit. You'd see symmetrical patterns. You'd see consistency. Instead, you see chaotic outgassing driven by which parts of the surface are currently facing the sun. This is what every comet does. You can watch videos of Comet 67P from the Rosetta mission. Jets everywhere, dust streaming off the surface, and that comet was absolutely, definitely not an alien craft. We had a spacecraft orbiting it for 2 years and a lander sitting on its surface. The difference with 3I Atlas is the chemistry. That unusually high carbon dioxide ratio tells us something interesting. It probably formed farther from its parent star than most comets in our system. Beyond what's called the CO2 frost line, where temperatures are cold enough for carbon dioxide to freeze solid. That's actually more evidence it formed naturally around a different star, not less. If this were a spacecraft, you'd expect to see things that don't match natural processes. Unusual materials, geometric structures, controlled deceleration, radio emissions, heat signatures that don't correlate with distance from the sun. We're not seeing any of that. What we're seeing is ice turning into gas. That's it. The alien spacecraft theory falls apart when you look at the actual data. It's a comet with interesting interstellar chemistry, which is way more scientifically valuable than another comet from the Kuiper belt. But it's not a probe. If 3I Atlas were actually alien technology, we'd see specific signatures, materials that don't occur naturally, geometric structures in high-resolution images, a trajectory that doesn't match gravitational physics, radio emissions that look artificial, heat management systems that don't correlate with solar radiation, controlled deceleration as it approached the sun. We're seeing none of that. What we're seeing is frozen volatiles sublimating when heated. That's it. Claim 2, it's releasing deadly chemicals. Videos claim 3I Atlas is emitting unknown toxic gases, that it could poison Earth's atmosphere, that these are chemicals we've never seen before. Let's go through what's actually being detected. The James Clerk Maxwell Telescope in Hawaii used radio observations to detect hydrogen cyanide. The production rate was between 1.5 and 4.5 times 10 to the 25th molecules per second. That sounds like a lot. It works out to about 1/4 to 1/2 kilogram per second. And yes, hydrogen cyanide is toxic. But here's the thing. Every comet produces hydrogen cyanide. It's one of the most common molecules in cometary comas. In fact, that distinctive smell of bitter almonds that people associate with cyanide. You'd never smell it in space. There's no air to carry it, and the concentration is so low that even if you were right next to the comet, you wouldn't be in danger. The ratio of HCN to water in 3I Atlas is about 0.2%. That's well within the normal range for solar system comets, which goes from 0.03 to 0.4%. There's nothing unusual here. Comets are full of organic chemistry. Hydrogen cyanide is a building block for more complex organic molecules. It's actually part of the prebiotic chemistry that might have helped life start on Earth billions of years ago. Scientists study it because it's interesting, not because it's dangerous. ALMA, the big radio telescope array in Chile, detected methanol, about 40 kilograms per second. That's higher than typical. But methanol is also common in comets. It forms when ultraviolet light hits water ice mixed with carbon-rich materials. And again, we're talking about gas dispersing into the vacuum of space. It's not concentrated. It's not a cloud heading toward Earth. Here's what people need to understand about space. It's empty. Really, really empty. When 3I Atlas releases these gases, they spread out over millions of kilometers. The coma around the comet is about 15 kilometers across where you can see it. But the actual gas extends much farther, and the density is absurdly low. You could fly through the coma in a spacecraft and barely notice. The molecules are so spread out that calling it a cloud is misleading. It's more like a very faint mist spread across a volume the size of a small planet. Now, let's talk about distance. On December the 19th, 2025, 3I Atlas will make its closest approach to Earth. It'll be 1.8 astronomical units away. That's 270 million kilometers. For reference, the Sun is 150 million kilometers from Earth, so 3I Atlas will be nearly twice as far away as the Sun. Mars, at its closest, gets to about 55 million kilometers from Earth. This comet will be 5 times farther away than Mars ever gets. The comet passed its closest point to the Sun on October the 29th. It was 1.36 astronomical units from the Sun, which is between the orbits of Earth and Mars. And at that time, Earth was on the opposite side of the Sun. We were nowhere near it. Now the comet is heading back out into deep space. It's already moving away from the Sun. And it'll keep moving away forever. There is zero chance any gas from 3O Atlas reaches Earth's atmosphere. The concentration would be so low by the time it traveled 270 million kilometers that it wouldn't be measurable. You'd need to collect millions of cubic kilometers of space to get a single breath. And the comet isn't heading toward us anyway, it's heading away. Even if every molecule of hydrogen cyanide the comet released somehow magically traveled straight to Earth, it would be diluted across the entire volume of space between here and there. By the time it arrived, the concentration would be less than what's already naturally present in Earth's upper atmosphere from other sources. The chemicals aren't unknown, they aren't unusual for a comet, and the comet never gets anywhere close to us. This claim is completely false. Claim 3. It's on a collision course with Earth. Some videos are saying 3I Atlas is heading straight for Earth. That debris will rain down on us, that we're in danger. This is probably the easiest one to debunk because the numbers are very clear. NASA's Jet Propulsion Laboratory has been tracking 3I Atlas since it was discovered in July. JPL maintains a database of every object in the solar system we know about. They calculate orbits, and 3I Atlas has an orbital eccentricity of 6.14. If you don't know what eccentricity means, here's the simple version. A circular orbit has an eccentricity of 0. Earth's orbit around the Sun has an eccentricity of 0.017. It's almost circular. An elliptical orbit has an eccentricity between 0 and 1. Halley's Comet, which loops around the Sun and comes back every 76 years, has an eccentricity of 0.967, still less than 1. When the eccentricity is greater than 1, you have a hyperbolic orbit. That means the object isn't bound to the Sun. It's moving too fast. It came in from interstellar space, it's swinging around the Sun once, and it's leaving forever. 3E Atlas has an eccentricity of 6.14. It's extremely hyperbolic. There is no version of physics where this object stays in our solar system. To put that in perspective, you need to be moving faster than about 42 kilometers per second to escape the Sun's gravity from Earth's distance. 3 Atlas is moving at 58 kilometers per second relative to the Sun at infinity. It has way more than enough speed to escape. The comet reached perihelion on October the 29th. That's the closest point to the Sun in its orbit. It was 1.36 astronomical units from the Sun, about 203 million kilometers, between Earth and Mars, and it's already past that point. Right now, it's moving away from the Sun. Its speed is decreasing as the Sun's gravity pulls on it, but it's still moving at tens of kilometers per second, way faster than escape velocity. The closest 3I Atlas will come to Earth is December 19th. It'll be 1.8 astronomical units away. That's 270 million kilometers. To put that in perspective, the International Space Station orbits 400 kilometers above Earth. The Moon is 384,000 kilometers away. This comet will be 270 million kilometers away. It is not close, and it's not coming back. When an object has a hyperbolic orbit, it means it came from outside the solar system and it's leaving the solar system. The Sun's gravity bent its path, but not enough to capture it. It'll pass Jupiter in March 2026 at a safe distance. Then it'll keep going. Out past Neptune, out past the Kuiper Belt, back into interstellar space. And we'll never see it again. What about fragments? If the comet breaks apart, could pieces hit us? No, When a comet breaks apart, the fragments follow almost the same path as the original comet. They spread out a little, but they don't suddenly change direction. If the main body is passing us at 270 million kilometers, the fragments are too. The European Space Agency tracked 3I Atlas with multiple spacecraft. Mars Express and the Trace gas orbiter watched it pass Mars on October the 3rd. The JUICE spacecraft observed it. They confirmed the trajectory. The comet poses no threat to Earth. The distance is so large that ESA doesn't even classify it as a near-Earth object. For context, Mars came within 19 million kilometers of the comet. That's 14 times closer than Earth will ever get. And Mars is fine. If the comet were going to fragment or change course in a dangerous way, we would have seen it happen at Mars. We didn't. 3I Atlas isn't coming anywhere near Earth. It's already past its closest point to the Sun, and it's heading back into deep space. This claim is false. Claim 4. Scientists don't know what it is. This one shows up in a lot of videos, claims that scientists are baffled, that it could be a planet or a brown dwarf, that it might be a mini-star, that researchers are hiding what they really think. We know exactly what 3I Atlas is. It's an interstellar comet. Let's start with where it came from. Astronomers traced its trajectory backward through space. The comet came from the direction of the constellation Sagittarius. That's toward the center of the Milky Way galaxy. Its velocity at infinity, which is the speed it'll have once it's far from the Sun's influence, is about 58 kilometers per second. That's 130,000 miles per hour. That speed tells us it's been traveling through interstellar space for a very long time. Analysis of its trajectory through the galaxy suggests it's between 3 and 11 billion years old. It likely originated in the thick disk of the Milky Way, which is a region of older, low metallicity stars. At some point, billions of years ago, 3I Atlas formed in a protoplanetary disk around a different star. Then something ejected it. Probably a close encounter with a giant planet. Or maybe two stars passed close to its home system and their gravity flung it out. It's been drifting through the galaxy ever since, moving through clouds of interstellar gas, getting pelted by cosmic rays. And now, purely by chance, its path intersected with our solar system. Could it be a planet? No. Hubble measured the size. The nucleus is at most 5.6 kilometers across. Earth is 12,742 kilometers across. Even the smallest planet, Mercury, is 4,879 kilometers across, and those are solid rocky bodies. 3I Atlas is showing all the signs of a comet: gas emission, a dust coma, brightening as it approaches the Sun, dimming as it moves away. Planets don't do that. Could it be a brown dwarf? Definitely not. Brown dwarfs are failed stars. They're at least 13 times the mass of Jupiter. Jupiter is 139,820 kilometers across. 3I Atlas is a few kilometers across. The size difference is absurd. And brown dwarfs emit infrared radiation from their own heat. 3I Atlas doesn't. It's reflecting sunlight and outgassing volatiles. That's comet behavior. Could it be a mini-star? Same problem. The smallest stars are red dwarfs, which are about 10% the size of the Sun. The Sun is 1.4 million kilometers across. 3I Atlas is a few kilometers across. It's not even close. And stars don't develop cometary comas. Scientists aren't baffled. They classified 3I Atlas within days of its discovery. The Atlas Survey Telescope in Chile spotted it on July 1st, 2025. Observations from other telescopes confirmed it was on a hyperbolic trajectory. By July 2nd, it was officially designated as an interstellar object. The third one we've ever found, after Oumuamua in 2017 and Borisov in 2019. The name itself tells you what it is. The 3I stands for Third Interstellar Object. The classification system is straightforward. If it comes from outside the solar system and we can prove it, it gets an I designation. We know its composition from spectroscopy, multiple telescopes breaking down the light into wavelengths to see what elements and molecules are present. We know its size from imaging. Hubble's resolution is good enough to put tight constraints on how big the nucleus can be. We know its trajectory from astrometry, tracking exactly where it is in the sky over time and using that to calculate its path. We know it came from the direction of Sagittarius, and we know it's heading back out into interstellar space. We know it's been traveling for billions of years. The only thing we don't know is which specific star system it came from. And we probably never will. It's been traveling for so long that the gravitational influence of other stars has changed its path many times. Tracing it back to one particular system is nearly impossible. But that doesn't mean scientists are confused about what it is. It's a comet from another star system. That's rare, that's exciting, that's scientifically valuable. But it's not a mystery. So which claim surprised you the most? Let me know in the comments. And if you want actual space news without the clickbait, subscribe. Because 3i Atlas is leaving the solar system in 2026, and there'll be more observations before it's gone.